Hello, my name is James Enlow, and today we are going to be talking about the Cryosphere. But first, let's go over what exactly the Cryosphere is and some facts about it. The Cryosphere is any part of Earth's system that is covered in frozen water. This includes ice, snow-covered land, frozen lakes, frozen rivers, glaciers, and permafrost. While the majority of the Cryosphere lies in Arctic and Antarctic regions, it also includes anywhere that experiences below freezing temperatures for part of the year and accumulates some sort of frozen water. Now, this relation to cold temperatures and conditions is where the Cryosphere got its name, with it deriving from the Greek word kairos, meaning cold. Also, since part of the Cryosphere lies in regions that are not always below freezing throughout the year, it shrinks in size by a large amount in the warm summer months, but rebounds and grows in size in the cold winter months. So now you may be asking, how big is the Cryosphere? Well, Antarctica is 98% covered in ice, and its thickness averages 6,200 feet deep. And in relation, 23% of the entire northern hemisphere is considered to be part of the Cryosphere. And you put all this together, the Cryosphere holds roughly 75% of Earth's fresh water. So now you may be thinking, why should you care about the Cryosphere? Well, the Cryosphere is vital to Earth's climate since snow and ice reflect solar radiation very well. This reflectivity prevents the sun from warming up the ground beneath, thus keeping the global temperatures in balance. With the Cryosphere containing such a large majority of the Earth's fresh water and it having such a large influence in Earth's climate, it's no wonder that humans are so interested in keeping track of its current state. So we'll now move on to the website itself, the Cryosphere Today. The Cryosphere Today is a web page brought to you by the Arctic Climate Research at the University of Illinois. The page is dedicated to presenting various charts, archived images, and forecast information, all pertaining to the Cryosphere. So we'll start here at the top of the page. We have a few different charts. We're going to look at two of them real quick. We'll start out with the current Northern Hemisphere sea ice area. If we look at the chart, we see we have the years 2014 to 2017 as our time span, and we are measuring this sea ice area in million square kilometers. And if you look, we can see we have a faint pinkish looking line here. That is going to be the 1979 to 2008 climatological sea ice area, just an average of the observed amounts over that span of years. We also have the light blue sea ice area, which is the current observed for the time span on the bottom. And also we have the sea ice anomaly, which is the red line, which is how much the observed differs from what is expected at that time. Now this is just for the Northern Hemisphere. We're going to look at something that is more global here real quick. This is a neat little interactive chart. On the bottom, we have days starting at 0 from January 1st all the way down to 365 at December 31st. On the left-hand side, once again, we have the sea ice area in million square kilometers, where on the right-hand side, we have the years from 1979 to 2017. If we look on the left-hand side of the chart here in the lower number days earlier in the year, is where we have the winter months. You can see where the sea ice ranges from anywhere about 13 million square kilometers to at the max at 15 million square kilometers. We can take a look at the max for that. That happened it was in the late 70s, if this would like to cooperate with me. 1988, where they had about 15 million square kilometers. There we go. I'm sorry, 1979, where they had 15.07 million square kilometers up here. And in contrast, we go to the summer months where the sea ice area is a lot lower. We range anywhere from about 2 million square kilometers all the way up to about 6 million square kilometers. And we'll take a quick look at the lowest observed sea ice area, which was more recently in 2012, where they had 2.26 million square kilometers. So that's a very large difference in the sea ice area between the largest recorded and the smallest. Another important thing to note on here is that with the years on the right-hand side, starting in 1979, we have the dark blue, and they get lighter, all the way to red for the more recent years. If you take a close look at this chart, A lot of the earlier years are in the upper parts of this chart, where as we get to the darker reds and pinks, they're in the lower. So you can see the trend of the ice levels lowering as we progress through time. So now let's move on to the heart of the page. This here is supposed to be, it's supposed to be a 30-day animation of the sea ice area. Now this is just the ice that is on the sea. This does not include the glaciers, the snow-covered land, frozen lakes and rivers and whatnot. This is just sea that has frozen into ice. We have the northern hemisphere here with the southern hemisphere on the right. These images are produced using satellite images, satellites that are orbiting in space. They use certain wavelengths to take pictures of the ice, if you will. So we'll take a quick close-up at the northern hemisphere one. You can see the continents here. We have the northern part of North America and the northern part of Asia over here. And in the middle, this is all frozen ice, which was once the sea that is frozen from the cold temperatures. This was taken yesterday, March 23rd, 2017. And this is measured in sea ice concentration percentage. So you'll see some of these bright green and yellow colors around the edges. That's where the ice is a lot thinner, a little bit more spread out. But as we hit into the pinks and the dark purples, that's where it's real solid ice. It's frozen there for a good while. So once again, over here is the southern hemisphere, real similar to the northern hemisphere. I would show you the animations, but they're not working for us today. But down here we have the Arctic weather forecast. What's given on this page here are from the GFS model output, or the Global Forecast System model. We have different variables of interest that you would use for forecasting the sea ice. We got wind vectors, air temperature, some geopotential heights, and down further we have some precipitation. I would load these up to show you, but they take quite some time to load, so for the sake of time we're going to pass on viewing these. It's just important to know that these conditions have a large impact on the sea ice throughout the year, so that's why they are including those on the website. And if we move down further, we see we have the northern hemisphere once again. We have the Arctic regions divided into 14 different regions. These are all parts of the northern hemisphere that experience sea ice very commonly throughout the year. So let's take a quick look, and we'll look at the Bering Sea over here, which is located over here in Alaska, or near Alaska. If we take a look at the bottom, we have the year span from 1979 all the way up to 2017. On the left-hand side, once again, we are measuring the sea ice area in million square kilometers. And we have the black line here with the peaks and valleys as the winter and summer months. This is the observed data for the sea ice area. And similar to the last one, the red line we have here, this is the anomaly, which is how much it differs from what's expected. Now, something that's real important to notice is the sea ice isn't consistent throughout the regions. It's a little bit different everywhere you go. So we have the Bering Sea ice here. It ranges anywhere from close to 0.8 million square kilometers all the way down to none. So let's take a quick glance at another region just to get an idea of how it varies throughout the area. Now let's go to the Greenland Sea over here. We can see it doesn't have quite as low of a minimum, but real similar. It ranges almost to 0.9 million square kilometers all the way down to its lowest being like relatively close to zero. So it's a little bit different everywhere you go. It all depends on those forecast conditions that we discussed earlier. Now lastly, let's move on to a chart that kind of shows you the big picture of what's going on with the sea ice. This here is the global sea ice area from 1979 to present. We have the years down here. It's kind of hard to see. It's a little bit small. But 1979 to 2017 million square kilometers again. And this just gives you a picture of globally how much the ice changes throughout the period of the year. And if you look closely, you can make out some of the outliers. Like in the 1980s, 1970s, you have two peaks right here, and then in the mid to late 2000s, I think in 2012 over here, where it was its lowest. So some of them stick out more than others, but that's a very good representation of how the ice changes throughout the year. That will conclude my presentation, and I thank you for joining me.